Okay. So let's skip out of the presentation mode and log into our equipment. Now to do this, we're going to have to do some automation as well. And this can be a little intimidating, especially for RF and electrical engineers that pride themselves on hardware more than software. But with the features on our equipment, it's really easy. So I'm going to be setting up my signal generator that I'm remote logged into here to do this. However, before I begin configuring the instrument, I'm going to come over here and hit Skippy Recorder and hit Start Recording. Skippy are the automation control, the messages that we send to an instrument in order to control it. So now that my Skippy is being logged, basically every button that I touch on the GUI is going to translate into a Skippy command that I can then use in my automation. Before I do anything, I'm going to change the configuration to be transmit coherent, as we talked about at the beginning of the presentation. Do that and click apply. And I'm going to set channel 1 to 30 gigahertz with a power of 0 dBm, and channel 2 as well to 30 gigahertz with a power of 0 dBm. I am then going to turn power on in both signal generators and open up the phase menu here and change my phase transition mode to coherent on channel 1. And on channel 2, also change it to coherent. I'll set the phase of channel 2 to be 180 degrees relative to channel 1. I have no corrections applied here, so this is going to be the phase at the output connector, not at the combined port of the analyzer. After that, I can come up here and click Skippy, and I can see here that all of the commands that I did via the GUI have been translated into Skippy commands. I'm going to hit stop recording and save this away in Skippy demo and give it a name, Skippy demo. This file is now saved with all the Skippy commands. Now that I've configured my signal generator, I'm going to minimize that and come over into my signal analyzer. I can see a signal here, but before I start configuring my signal analyzer, I'm again going to turn on Skippy Recorder for this instrument as well, so that I can record everything that I do via GUI. Next, I'm going to switch from the Spectrum app over into our channel power application, which is part of our Spectrum Analyzer suite. I do this just because it'll make quicker power measurements. I'm going to change my center frequency to 30 gigahertz and narrow down my span a little bit to 2 megahertz. Switch over into bandwidth, and I'm happy with the bandwidth of the 18 kilohertz resolution bandwidth. I'm then going to set my sleep mode into single sleep and turn off averaging because the sensitivity of the M9484C is very good, and so I'm not worried about driving down my noise floor. I'm going to be measuring fairly large signals here. I can click restart just to measure again and see that I'm measuring the signal. And then I will turn off the Skippy recording, come into the settings, go to Skippy Recorder, and I can see all of my commands here. I'll click copy and move them over into a notepad I have here on my other screen. One final thing to note is that I'm going to be querying this value right here, the total channel power, which measures the power integrated over the span of my measurement. Here, because the power of my main signal is so much larger than the noise floor, I'm going to effectively be measuring the main power. If your signal starts to get close to the noise floor, then you may want to consider using something like a marker instead of this total integrated channel power. In order to know how to query this value, because that is something that's not captured with the Skippy Recorder, I'll click the question mark and come into the help menu and simply search total channel power. And I see here for the channel power measurements, I get this command. I'm going to scroll down to the queries, and I'm going to use this read channel power command. And I'll copy that over into my notepad on the side here as well.